A very good morning to Madam and all. So let me introduce myself first. My name is Fung. Today I will present about molecular techniques and tools, which is ELISA assays. To begin, I would like to explain about the history. In 1960s, one enzyme called as enzyme linking that developed by strategist Evermers and GB Peirce. At the same time, White and J. was successful to publish immunosuppressant preparation techniques. At 1970s, Eva Ekman and Peter Perman was successful to publish the paper research called as ELISA assay. For introduction, ELISA assay, also known as enzyme-linked immunosuppressant assays. ELISA assays commonly use analytical biochemistry assays. This function is very wide, uses as diagnostic tool in medicine as well as quality control checks in various industries. Next, I will present about the molecular basis of the techniques. So in ELISA assays, there are two parts, which is antibody ELISA and antigen ELISA. Part A, antibody ELISA, will talk about the antigen are stuck onto a plastic surface. The plastic surface is meant to be the plate, microplate or 96 well plate. The antigen will stuck onto the plastic, the surface. Then the sample is added and any antibodies for the disease inside the sample will testing for binding to the antigen. If the complementary antigen and the antibody then will bind together. After that, the solution inside the plate will washing out. Then it will be added to another solution that brings second antibody with a marker is added. So the second antibody will bind to the first antibody that inside the sample of the disease. If positive fraction is detected by the marker, the changing color will occur. But for the negative fractions, when no antibodies for the sample is stick to the antigen, so there are no color changes. So for the part B, antigen ELISA is similar to antibody, but for this antibody are bound to a plastic surface. The antibodies for the sample is attached to the 96 well plates or another plates. So the sample is added and any antibodies for the disease is testing for the binding the antigen. Then it is to washing out the second antibody that with a marker is added with another solutions. So it seems with if the positive fraction is detected by the marker, so the color changing is occur. But for the negative fractions, there are no antibody sticks and there are no color changes. So the next part, I will explain about the laboratory tools and machines involved. So basically, there are so many machines that involved in this assays. For example, cold storage that for the sample where it's placed, and the reagent reservoir, well-washed microplate washers that wash out all the solutions. Then ELISA conjugate. There are some kits that involve this, which is ELISA kits, single channel pipettes, pipette tips, multiple channel pipettes, cord plates, 96 well plates, stop solution, and wash concentrate. For the more important is enzyme and specific substrate. There are some enzymes that involved in this and specific substrate. For enzyme, for example, it's horseradish peroxides as a peroxidase and alkaline phosphate. The next for specific substrate is all phenylenediamine dihydrochlorides. For the next is p-nitrophenyl phosphate PNPP that involved in this assays. For the research, I found that some research is related to the ELISA assays, which is the HIV antibodies in blood. For the HIV antibodies in blood detected by ELISA, it detects the HIV antibodies and antigen in the blood. So antibodies are protein produced by the immune system. So as we know, the antigen are any foreign substance in the body. So for the experiment used in the immunoassays for the HIVP24 antigens and antibodies to HIV 1 and 2. As we know, the blood sample will be added to cassettes that contain the viral protein, which is the antigen that will complementary with the antigen of antibody that at the surface of the cassettes. So the positive sample that will have complementary antigen and antibody will bind with the antigen and causes the cassettes contents to change colors. So The test detect HIV antibodies which the body starting producing between 2 and 12 weeks. Next, I will present about the picture that related to some picture that related with the ELISA assays. So the first picture, there are this present about how the ELISA assay will ongoing for the mechanism. So there are 4 steps, which is coating, blocking, detection, and read results. In coating, the polystyrene plate, which is also one of the plate that can use for this assays, is treated with the solutions of either antigen or antibody. So the antigen or the antibody will attach to the surface. So the next is this will remove the liquid and wash the plate by the machines. So next is the blocking. Blocking is talk about the unrelated proteins. The base on the solution is used to cover all unbound sites on the plates. So that means the sample with complementary antigen and antibodies will attach to the antigen or antibody that at the surface of the plates. Then after that, the next step is will be remove the liquid and wash again the plates. So the next is the detection. Detection is use the enzyme conjugate antibody or antigens bind specifically to target antigen or the antibody. So the liquid or the solution will be removed again and then wash the plate again. So the last step is the read result. The read result is the substrate is added and the signal produced by the enzyme substrate reaction is measured. So we can know how much the concentrations for the sample has that the disease. So next, I will present about the types of ELISA that involved in this assays. There are 4 types in this assays, which is direct ELISA, indirect ELISA, sandwich ELISA, and competitive ELISA. We look at the direct ELISA. So direct ELISA is like direct for the sample, and antibody for the sample will attach to the antigen and give the substrate, and it will directly give the result. For indirect ELISA, we can see that there are 2 antibodies. So that means after the sample is added, so another conjugate protein will added for the secondary antibody to attach to the first antibody and bring the marker together, then give the result. For sandwich ELISA, there are three antibody there, which is the first is capture antibody. Capture antibody is the first antibody that used for the surface of plate. Then the next the sample is added. Then the antigen will bind to the antibody that bring the secondary antibody conjugate. Then it will give the result. So that means this procedure is use antibody for the first region to attach to give result for the antigen for the sample. So the last one is the competitive ELISA. Competitive ELISA contain the inhibitor antigen and the antigen as the region that will give result to the antibody for the sample and give the last result. So the next is the picture is related about the mechanism detection of HIV by ELISA assay. It's similar to the like before this I explained about how the process mechanism is ongoing. So the next is about the HIV assay diagnosis testing evolution. So it got from 1985 years until 2015 years. They are from several generations, which is 5 generations, from using the indirect ELISA until the sandwich ELISA, and the last one is also the sandwich ELISA, but plus some antigen or antibody that related to this samples. In conclusion, we know that ELISA assay can apply in many sectors, either in medical, industry, laboratory, or medicines. So the cost is very cheaper than another experiment. It's about the save time, save energy to doing this experiment. So the detection of sample is very wide, either in disease, virus, or any organism that will be related about the antigen and antibody. So the last part is about the reference. So these are my reference that I refer to this all the journal and doing this ELISA assays. So that's all from me. Thank you.